Every 11 seconds, there's a new ransomware attack. Oil pipelines, universities, corporations, all paying millions of dollars. Barracuda says, don't pay the ransom. Before a ransomware attack occurs, train your teams to recognize an attack and use anti-phishing technology. Protect your applications, and they can't get onto your network. Simple backup and restore solutions quickly recover your data without paying the ransom. Build your ransomware protection plan now by visiting securityweekly.com/Barracuda. That's securityweekly.com/Barracuda. Welcome back, everyone, to Paul's Security Weekly. Join us in our next live webcast on October 21st to learn why zero-knowledge encryption matters with the fine folks from Keeper Security. Visit securityweekly.com/webcast to save your seat. Don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. This segment is sponsored by Invicti. To learn more, please visit securityweekly.com/Invicti, where you can find our fine friends at Acunetics and NetSparker. Joining us for this segment is Sven Morgenroth. Sven is a security researcher for Invicti and joins us today to talk about GraphQL APIs and their security. Sven, welcome back to the show.
Thanks for having me again. It's always nice to be here.
Yes, nice to have you, and nice. I like the topic. I like GraphQL. Every time I look at it, I'm like, wait, we need to be using this in our applications. This is pretty cool, actually. Although after this segment, I might change my mind.
Yeah, I mean, it's a pretty cool technology, actually. Like, it was developed by Facebook. I will go into detail a little bit more later about it. But yeah, I mean, I'm a fan of it. It is like a little bit tricky security-wise. You will see why in a minute. But yeah, in general, I don't advise you to not use it. I just would advise you to be careful about it, if anything, and read the documentation and like be aware of like the general pitfalls that you might encounter if you are using it. If it's okay, I will share my screen now so we can have a look at the presentation I prepared for this.
Sure.
Right. Can you see everything? Okay, perfect. So let's start with a little bit of general knowledge about GraphQL. So what is GraphQL? GraphQL is a language for querying and manipulating data through APIs. And back in 2015, it was publicly released by Facebook to be used. But internally, they were using it before then, in as early as 2012. For the iOS mobile app, they were using it for their news feed. And since then, like about every programming language that you can use to write applications in is capable of like running GraphQL APIs. That includes JavaScript, Python, PHP, Ruby, Java, Go, and like many other languages. And yeah, the cool thing is it uses a standardized language, and usually you can transmit it via JSON post or via GET requests, though that is not the only thing you can do. You can also use WebSockets, for example. Like I think the Apollo framework supports this. And yeah, it's generally very versatile. There are a lot of add-ons for it, like you can have, for example, file uploads and stuff like this, all on top of the base GraphQL specification. So what are the advantages? Like one of the most important and most useful advantages is that you can fetch all the data you need with a single API call. It allows you to selectively query data and lets you choose the fields that are required for your specific use case. For example, you can imagine some endpoint that would return user data like the email address or like the username and stuff like this. And depending on where you need the data in the application, you can just send a API call to that specific endpoint, and then
now Sven,
get all the.
when you're describing this, you have to use the student and the teacher and the school analogy, because that's the standard. I asked my nephew who just started at college, and he's like, I'm learning Java and object-oriented. And I'm like, let me guess, you're starting off with a student object. He's like, yeah, how did you know that?
Yeah, I mean, within this slide, these slides, I will use like authors and posts and stuff like this, but it's a similar concept. So yeah, I mean, it's the most easy thing to get the point across, I guess. But yeah, we will look into that in a little bit more detail later. But yeah, it's very useful to just have one endpoint, and then from your front end you have similar multiple different places where you can query data from it, and you only get the data you actually want and not any overhead with it. And that is just saving bandwidth just by avoiding redundant requests and too much data that is sent from the API to your front end. And that was also one of the initial reasons for its development, because I think back in 2012, they were having some issues with like all the data that you would need to query from the API in order to get it into the app, and it would produce a lot of overhead. And you had this very like interconnected these interconnected topics and authors and stuff like this, and it wasn't like the best thing to use with a REST API. So the people at Facebook probably developed it for reasons that had to do with this. Another advantage is that it is very easy to integrate microservices into your API. So if you have some other legacy API that you want to use with GraphQL, you can even do that. You can query backend services from your handler function. That is basically where your application logic resides. And yeah, the other useful thing is that it ships with validation and type checking. This is done using schemas. And yeah, that's also a very, very useful feature that I personally try to use in my REST APIs as well. But it is, it's like shipped out of the box in GraphQL for like GraphQL APIs, and that's a pretty cool thing. So you may ask yourself what GraphQL schemas actually are. So basically, they are describing the layout of your GraphQL API. They are written in the GraphQL schema definition language, or short SDL. And it lets you define fields that hold your data, basically. There are integers, there are floats, strings, booleans. And for all of these, the type checking is enabled out of the box. However, there are also custom scalars that you can use and define yourself, which don't have the type checking enabled, because you're like free to do with them whatever you please. And that's like the first pitfall you need to be aware of, because if you like expecting some custom scalar, like date is a popular example for this, or like just a date, then you might run into issues, because it doesn't prevent you from sending anything other than a date. You might also send like a string or something like this. And it's generally something you need to be aware of. It also supports arrays, objects, and GraphQL specific types, like ID is one example for this. Like the name suggests that it could probably be a numeric identifier, but you're free to use whatever you want. It's basically the same as a string. Like the ID type is just like telling you to be careful that it should it could contain some identifiers and must not be readable for human, but it is basically a string value, even if that's a little bit confusing. Right. You can also define whether fields can be empty or not, which is useful because you spare yourself a lot of boilerplate code if you have it right in the definition of your schema. And yeah, so the cool thing what schemas actually force you to do is write accurate documentation for your API, because like the documentation is basically what your API consists of. Yeah, and the added benefit of type checking, of course. So if you're done writing your schema, you basically have your documentation right in front of you with all the types that are expected to be passed and what the API is returning. And usually you don't have that with REST APIs, at least not like in that convenient way. So additionally, you can define arguments, and that's where things get interesting, I guess, from a security point of view, but also like from the usability, because this is where users will pass input to your API. So arguments also have their type specified in the schema. And if the type of your input is not the expected one, the API will return an error message, which is pretty useful and may avoid some bugs that are due to unforeseen like types, especially some NoSQL injections or SQL injections, maybe even if you're expecting some type some input always to be an integer, but nobody really checks whether it is. So some developers might just put it into their SQL query without any further sanitization or like without using prepared statements, and then like yeah, that's where things get ugly. So you can also define GraphQL queries and mutations. Queries allow you to read data. Mutations allow you to create, update, or delete it. And yeah, if you're familiar with like the best practices in REST APIs, that you maybe should use GET requests only for reading data, then you are probably also familiar with the fact that nobody like really does this, or like a lot of people don't, at least. And some state changing stuff may even happen with like queries, even though you probably expect it to only be done in mutations. All right, so application level code, is handled in so-called resolver functions, which I talked about a little bit earlier. Yeah, that is where the data is aggregated and then returned to the user. So let's look at GraphQL schemas, and I took all the examples from the Apollo documentation. Apollo is basically a GraphQL library that is like very good in my opinion. They have all the extra features that you maybe are missing from the vanilla GraphQL specification, and they also like wrote some own standards. I think the file upload functionality I mentioned before was also like introduced by Apollo, if I remember correctly. So yeah, they have pretty good documentation about stuff, and yeah, also some extra features. So here you can basically see a very, very basic GraphQL schema, which has two types: a book type with like a title field and an author field. And the author field is also a type which is like the author field contains some data in from the type author that you can see here below, which also has a name, which is a string, and books, which is an array of like the book type that you've seen before. So you already see that they are somewhat connected and reference each other. And yeah, that is a pretty cool feature, but it also leads to issues that we can see later. So how do you actually query data from like a database with that definition? So you send your query like this. You have a get books and authors query. You want only the title from the books, and you also want to have the like the respective author, and only want the name of them. So yeah, it may look like this. If you're getting back the data, it will show you the title, only the title, not anything else, and only the name of the author. Even though, like internally, you could use a lot of other like fields apart from that. There's also the mutation type that I mentioned before. In this example, you can add a book with the where you can specify the title, which is a string, on author, which is a string, and it will return some data from a book type. So this could also be integer. It could have an exclamation mark here, which would tell you that it is required. I think that's how it works with mutations. And yeah, if you're passing the wrong type here, it would just send you an error message back, and you couldn't it wouldn't really hit your the application level code. It would just it would handle all the type checking and stuff before you even have to do with it. All right. That might look like this. So you add a book with a title, Fox and Socks, the authors, Dr. Seuss, and you will get the you will get the data back. For example, like the title will be returned, and the string you pass here will be the name of the author object, basically. So you can see this here. We have the title that we specified before. We have an author object with the name that we also passed before. Like if you would want to add more data, you could also use a mutation query to update the data set you put in there before, and then maybe add some release date for the books or something like this. So yeah, it has automatic type checking and documentation. So what can go wrong? Like if I ask a question like this, the answer is obviously a lot. Like type checking and the readable documentation are must-haves for secure APIs, in my opinion, but they aren't the only requirements. You also need proper authentication and authorization. You want rate limiting for certain functionality. For example, you don't want any denial of service attacks if you query some resource-intensive stuff. And you optionally only want trusted developers to be able to read your API documentation, because like if they aren't allowed to like query your API, they also don't really need to know which data is in there and how you can get it and stuff like this. The thing is that none of this is the case out of the box, at least for GraphQL.
What could possibly go wrong?
Yeah, right. So we have authorization issues, and these are one of the most common security issues in GraphQL. Because implementation authorization can be confusing, and if you're not using the best practices, it can also be quite tedious. So due to various connections between the different types that you can specify, as we've seen before, there can be many routes to the same data. For example, there could be multiple ways to retrieve posts from an author, even as part of an author type, to get all the posts by an author, or like you get the posts directly via an ID with another query. And if you don't implement your authorization checks consistently or in a central place, you can easily run into issues. Because you may just forget to apply the checks in a specific query that accesses some data that shouldn't be accessed by anyone apart from if they aren't authorized to do so. So GraphQL does not automatically take care of this. I think there are a lot of recommendations about how you should go about it. For example, you shouldn't do it like in every single place where you query data, but you should do it in a central place, and then call like a certain function to get the data, and then within that function you should do your authorization checks. Yeah, I mean it's not the ideal way to do things. To be fair, though, in a lot of REST API libraries, or if you implement a REST API yourself, you also don't necessarily have some way to do this easily and have to add your own logic if you don't use a framework that supports it, but rather some like very basic stuff or implement it yourself. So yeah, it's like GraphQL doesn't really do it in a straightforward way. But yeah, they aren't the only ones who have problems with this kind of issues. So next is denial of service. And yeah, there are like some problems with recursion. I mentioned this in one of the earlier slides. If you have a query like this and you get books and then the author and his books again, and then another author and so on, if you are stacking queries like this, you force the server to issue requests or write log files or execute other resource-intensive operations over and over again. And yeah, this is a very simple denial of service attack vector that is very hard to prevent and easy to abuse. Yeah, this is just due to the fact that there are almost no requirements on the attacker side in order to exploit this. Like they don't need a full-fledged botnet in order to like send a query like this. They could basically type all of this in like the whole payload into their phones if they are just bored enough. Like there's nothing very complex about it, and nothing very nothing that requires a lot of bandwidth or a lot of computations, or like a very powerful machine on the side of the attacker. Yeah, it's a bit unfortunate, and
yeah, it's weird, Sven. It's like it has like a loop built in without writing a loop kind of thing.
Yeah, kind of like that, exactly. It's like a very like very easy to exploit thing, and it's not very straightforward to prevent this. There are different approaches to it. For example, you could just prevent this recursion to a certain degree, which wouldn't really help you if you like have like, I don't know, 10 levels deep of these recursions and stuff, but have some very resource intensive operations that you have, and you will get a denial of service attack anyway, even if it's like limited to like a low number of these recursions and stuff. What you also could do is assign individual like score points to each of these types, and score them based on the complexity and like the based on how much computations, how much power you need to have in order to fulfill like the query. This is like not really straightforward in my opinion. So and sometimes you don't even know which of your queries are that resource intensive, because maybe you run into some weird bugs that may only show if you're querying it like often enough, and maybe you have a weak backend microservice that you're querying that might just throw some rate limiting errors and stuff if you are using a query like this, and it wouldn't show up in your usual tests, so you aren't really aware of it. And like a score-based system is also not like the best thing to prevent this. So yeah, it's not easy. I think the most sane approach is still to prevent the death of these these stacked queries, and like optimize it in a way that it will not lead to denial of service attacks, even if like an attacker would abuse it like that. There are also other things you could do with stacking queries and sending multiple queries in one request. For example, if you have some check for a second second factor authentication, I mean, then you could just send, I don't know, like 60 or 600 or whatever, however much attempts within one query. And if you're only using rate limiting on top of your GraphQL API, then this will also lead to problems, because it will just be one request that your plans will see, and not like 600 that you're actually sending. So it can be really tricky to prevent stuff like this. I'm pretty sure there should be some middleware for you to handle this. And I think there's like a lot of middleware for GraphQL in particular, just because it's so customizable, and you can have a lot of use cases where GraphQL could be fitting, but it's missing some very basic stuff that would make it useful for your application. A lot of people implement this as middleware, and it is widely available. So you should really look into enhancing it with some like well-tested and established middleware for things like this. All right.
So by itself, you can't prevent it. You need to add that middleware to really make sure that it. I'm having flashbacks to when I was learning the wrong way on how to do recursion. It's bad when you get it wrong.
Yeah, it really is. Like we probably all that were programming in any language were having some issues with recursion in one way or another. And like, it's really frustrating. I know it from my personal experience when I implemented something that was using recursion on purpose. Like if you use the recursive function, for example, to scan some directories and stuff like this, and then you have a slight error in there, and your browser will start to hang, or your application in general. Like it's frustrating, and like I guess it's the best way to showcase how annoying and like a difficult denial of service attacks like this can be, especially like if you were programming with it and like maybe had to restart your computer because it was just using maxing out your CPU or your RAM or stuff like this. So yeah, I think it is a really good example on how you can get a feel for the annoyance of denial of service attacks.
Yeah.
So there's also a thing called secondary context path traversal, which I can tell you is also very difficult to detect, and maybe it's annoying a little bit, because one of the cool things you can do with GraphQL is just putting it on top of some legacy API and use it out of the box until you maybe have a better solution for it. And so it's still a little bit dangerous to talk to microservices via your API. It's not GraphQL specific. It's like that for other APIs as well. But so it's without proper sanitization, you may be able to interfere with the communication with microservices, especially in HTTP requests. So imagine a query like this. You just want to get some public posts from the author Alice, and then it should give you an array of posts back. It on the back and your microservice might have an API that works like this. You have your get posts by author endpoint, and then you will get the author name here, like some neat REST style yeah, and some REST URLs. And it may return something like this, like an array with the author, who is Alice, with the content, and so on. And your GraphQL API will just proxy that back to you as like the posts field. Now imagine if you would specify an author like this. This will just like you're probably familiar with the double dot and then the slash, and it will basically go to the parent directory. And suddenly you will end up with a URL like this, where you don't get the post by author anymore, but want to get all the private messages from the users. And of course, like the API will happily send this back to you, because a lot of the times the authentication, authorization is handled by the front end, and somewhere along the way the user context is just lost, and the API will just talk happily to the front end and without any authorization checks, because it just assumes that they were already done before, and the API server is aware of like the context of the user who wants to get all the data. And
so
obviously,
Sven,
like
in this, I'm sorry, in this context, I send a request to GraphQL. GraphQL then basically proxies that off to another microservice. That microservice trusts whatever is coming from GraphQL, and then the response gets trickled back down to the user, essentially.
Yeah, exactly like this.
Gotcha.
That was well explained. It works like this, and it might lead to problems because the microservice inherently trusts the GraphQL API, and it isn't aware of like the path traversal issue there. So it will, it will basically give you back data that you shouldn't have access to.
Oh wow, that's like SQL injection on acid.
Mm-hmm.
Yeah, that's also a good way to put it. True. Then there's like the last section of my slides, which is discovery. And the big question is, as a pen tester, what are you doing if you're running your directory fuzzing and use something like FUF to get some directories on the server, and you will see a GraphQL and GraphQL endpoint popping up in your output, and you have no idea what it does. Like, you don't have any additional context. Maybe it's a weird subdomain that is only giving you back the GraphQL API endpoint, and you don't know what to do with it. You may have a hard time understanding what data it accepts and what it actually does. It's especially annoying in combination with the type checking and some mandatory arguments that you may need to pass in order to get back certain data. And we'll just tell you that you didn't like specify some required arguments. Luckily, there are a few tricks that may help you to figure out what input the API expects. Like, the first trick is using autocorrect. Actually, GraphQL has an autocorrect feature. And if you send a query like get psts without the O, GraphQL will just send you an error message stating that the name is invalid. In some cases, it might even correct you. So it will state that you likely wanted to write get posts instead of the missing O above.
Thank you.
As an attacker, this is kind of useful because you can just throw a lot of stuff on the wall and see what sticks. And the feature works like this in Apollo. At least I think that's also an Apollo feature. I'm not sure if it's in the GraphQL standard or not, but I think some of the GraphQL frameworks implement this for you. This feature takes the editing distance into account.
What do you mean by Sven? What do you mean by editing distance?
It's an eigenvector. Go ahead.
What?
It's an eigenvector.
didn't-
It's how far away from the problem is the thing that like if you put GT instead of get, it wouldn't know to put posts in there because it's too far away.
Too far away. Okay, I gotcha.
Yeah,
Sorry.
that's right. It will basically check how many of the like
Characters.
exactly. How many characters you are away from the
Mm-hmm.
from some existing fields and queries and stuff. So if you are, I think there was some research about it and some very specific number. I think the threshold was like 0.4 times something. I'm not really exactly sure. Like there was a great talk about it on some background level up talk. And by choosing certain word combinations, you're able to effectively brute force longer words with short letter combinations, and then reduce the amount of tries that it takes to actually to come up with something that is actually useful for you. So you can you can make it very effective to brute force some long lists of common fields without without sending all the data and maybe sending a lot of large requests or getting rate limited or stuff like this if these batched queries aren't supported. So that it's a neat trick to save you some tries and maybe even discover some queries mutations, stuff like this that you weren't even aware of or didn't have in your word list if they are just close enough to what you put in there. And like the even more popular thing to do, which is like really useful if you're a pen tester or a bug hunter or something like that, you can in some cases even retrieve the full schema, which is very cool. You can use a so-called introspection query for this. And what this basically is a special query that allows you to get information about certain queries and fields and even lets you reconstruct the whole schema. And the cool thing for a pen tester and the not so cool thing for a developer is that a lot of the GraphQL frameworks don't even have an option to disable the introspection queries, which is like unfortunate for you if you're developing an application and don't want anybody apart from your like trusted developers know how to use the API. I mean, it's obviously not really a security thing to hide your to hide your documentation for your APIs, and then just hope that nobody will will find your heap dump endpoint or something like that. But I mean, it's still like in some cases useful to hide your API and not have let everybody know what data is in your API or what can be queried or which fields are available for all the for all your different endpoints and stuff. So the middleware you can use for this is sometimes very basic and will search for stuff like some double underscores for within queries or something like that. And you have to be aware of the middleware, what it does, and whether it's sufficient enough to prevent road introspection, but I meant road retrospection, but I meant introspection. But it's you should be aware of the middleware and if it's sufficient to prevent stuff like this.
Mm-hmm.
So I don't know if this messes with the view. I hope it doesn't. But this is a basic example for some. Can I zoom in a little bit more? Okay.
Yeah.
This is a basic example for some introspection query. Like you can get the name, you can get the fields with like the field names, and it's a really very useful thing to have if you're pen testing a GraphQL application.
It kind of sounds like Active Directory, which is super helpful about answering queries about what is on the domain. This is everything that's on your API, right?
Yeah, I'm not too familiar with Active Directory, to be honest. But yeah, if it has a similar feature like that, you really can appreciate like how useful it is to have it if you're an attacker, for example. So the conclusion: how secure is GraphQL? I would say, as I said in the beginning, that it is not less secure than any other ways to design your API. There are pitfalls that you need to be aware of, as we've seen, but like this is true for every technology you use. And I think with stuff like REST, you're even a little bit more on your own, because like you have a certain kind of standardization in there, but you are lacking the automatic type checking and like the forced documentation that your schema provides to you. And I think from a security perspective, this is very useful and like is really a great feature to have. And so in general, it's a great tool to use, in my opinion. It can improve bandwidth consumption if you're willing to deal with some of its complexity, because like, to be honest, it's very, it's tedious to write everything into your schema and then define like your resolver functions and then get the arguments from there. And yeah, it's a little bit easier with REST, but like the added benefits it can provide to you in terms of like the bandwidth consumption, in terms of avoiding some boilerplate code, and having one API for one endpoint for different parts in your front end is just super useful, and even saves you some headaches with versioning and stuff. So yeah, I mean, in general, I think GraphQL APIs quite a cool thing to use, and I wouldn't just advise against using them just because of the security issues I mentioned before, because if you're aware of them, you can easily avoid them, or sometimes avoid them after some considerations in terms of like usability and some risks you might have with denial of service vectors. And if you come up with need to come up with some other maybe more creative solutions to avoid them. But yeah, I mean, that's as always, it's a trade-off between usability and security, and whether you want to use it or not is like depending on your use case and whether you want to have this additional overhead. And yeah, all right, that's basically my opinion about like the security of GraphQL, and I think it is a cool technology.
Sven, when you say that you can use middleware to potentially filter out these queries, what's an example of that?
I mean, for NPM, for if you're developing a Node application, there are a lot of tools you can just add for you. Usually, you would use the Express framework, most likely for GraphQL. And GraphQL itself is is implemented as an Express middleware. Like I think the official GraphQL.js library is used like that. And I mean, you can add some more middleware on top of it to just inspect like the incoming requests and check whether the introspection query, whether it contains an introspection query, or maybe some other dangerous some other dangerous stuff, like maybe even like the recursion I've mentioned before. Like I'm not 100% sure there's middleware for recursion, but probably there is something that you can use or like write on your own, maybe, because it's generally really easy to write middleware for that kind of stuff. So yeah, I mean, if there's no there's a lot of stuff you can choose from, and maybe some settings within your GraphQL library, like in Apollo. I mean, I've mentioned that library in particular a lot, but just because it's like very mature and has a lot of features that will also save you some headaches and like security-wise and usage-wise. So
Sven,
that is. Yeah.
So if we were looking to start getting into doing some testing against and looking for some of these types of issues, what kind of tools would you recommend? Like something like Postman, or is there something better?
Yeah, I mean, the issue with GraphQL that is also like a little bit unfortunate is that even though it's been out since like some time now, that you haven't seen like adoption of it for some time, because like as you know, and a lot of projects like changes like changing your whole API for something else are really like slow and sometimes not even possible at all. And you have, even though you have GraphQL out for quite a while, the adoption is still increasing, and some companies are switching to it, and therefore also a lot of the security tools aren't there yet, because they will usually allow you to use stuff like I don't know, some post or get requests, and not really, or maybe even JSON, but not really some the type of requests you need to send in order to talk to a GraphQL API. And yeah, we are currently working on implementing GraphQL support in NetSparker, which will enable like a lot of our existing checks with GraphQL where it makes sense. And yeah, I mean, you will have a whole lot of existing checks just working out of the box with NetSparker with it. I'm not really aware of a way to test it with existing tools. Like there are probably some ways to use SQL map or stuff like this with GraphQL if you're using some creative tricks to get it to work.
It looks like Sven Burp Suite has a module. It looks like it might have been contributed. It was last updated in August of 2019. It's called GraphQL Raider, but obviously, a little dated in an add-on module. I don't know if anyone's used it before, but
I have not. Yeah, and Postman for doing API stuff like that would be my go-to, and Postman does support GraphQL, but I haven't encountered anything that I've needed to use it against. So,
but obviously these are more manual testing tools, and Sven having
Postman
this
supports Graph.
Yep.
There is a module, Josh, called GraphQL Raider.
If I was for Burp, Josh said Postman supports.
Oh, Postman supports.
Yep.
Sorry,
it does.
I did not know that.
But obviously,
Super
Sven,
cool.
Having it in NetSparker that's super awesome.
Some automation.
Yeah. I agree. The automated approach is a pretty good one when it comes to big APIs in particular. Like I think just as an example as a very big API that supports introspection, I think, or maybe it has some good documentation. I read it somewhere, but I think it was GitHub that has like several thousand lines of code of schema definition, and like it can get very complex real quick.
Mm-hmm.
And doing that manually is first of all very tedious, and second of all maybe not even possible within like the time frame you have, and whether you are implementing some new features and add fields here and there, and you may want to have that instantly, or maybe within your SDLC, and like that is not really possible if you're just doing it manually or with some attack proxy or something like that. It's just like a matter of scale, and yeah, it might still lead to some missed vulnerabilities if you do it like that.
Outstanding. Any more questions, comments?
None.
I just want the light he's got in the background.
Want the microphone? Come on now.
The microphone and the light. I want the light and the microphone. Okay.
Very
All right,
cool.
I'll send you some Amazon ref links if you want.
There you go.
Perfect.
Universal shopping.
Yes.
Sven, thank you so much for appearing on Paul's Security Weekly.
That was awesome.
So thanks for having me. It was fun as always.
This segment was sponsored by Invicti. Please visit securityweekly.com/Invicti. Next up is the security news, where there is an awesome high school prank that we'll talk about. Stay tuned.